So this is going to be the end of section 4.3. This is about my fifth start at this group of problems. I just can't get the words out how I want to get them out, and eventually I'm just going to have to live with whatever I come out with. So if it's kind of clunky, well, at some point I've just thrown in the towel and I'm just going to take what I have. So each one of the problems between 13 and 24 is an equation that's going to graph to be a parabola. And ultimately we're going to be asked to graph this equation. But before we go to graph the equation, we want to describe the transformation compared to f of x equals x squared. And that's not particularly easy to do if the function isn't written in a form that helps me understand the transformation. Ultimately, I'm going to use a strategy called completing the square, which you learn in intermediate algebra, to rewrite the problem so that I can tell you, compared to the graph of x squared, whether it's shifted left or right, up or down, if it's reflected over the x-axis, if it's wider or narrower. So I'm going to get started in each one of these problems by using completing the square to rewrite the problem in standard form. And it's really, I'm going to rewrite the equation of the parabola in standard form. So I'm going to take the equation that's given to me, and I'm going to write it in a form that possibly has a number times a parentheses with a square, and inside that parentheses I could have a plus or a minus sign, an x and a plus or a minus sign, and then a number. And then after the parentheses with the square, I could have a plus sign or a minus sign, and then some number. And then once I get it written in that form, I should be able to describe how the graph of my function compares to the graph of a generic f of x equals x squared. Very specifically, if this a is a negative number, the graph is going to be reflected over the x-axis. And then if I make the number positive and it's bigger than 1, the graph is going to be narrow. And if when you make the number positive it's between 0 and 1, the graph is going to get wide. So the number in front of the parentheses tells me if the graph is narrow or wide, and if it gets flipped over or not. If it's negative, the graph gets flipped over. We say it gets reflected over the x-axis. And if I ignore any signs, if the number is bigger than 1, the graph gets narrow. If it's between 0 and 1, it gets wide. Inside the parentheses, if there's a plus sign, it's going to move the graph left. If there's a minus sign, it's going to move the graph right. After the parentheses, if there's a plus sign, it's going to move the graph up. If there's a minus sign, it's going to move the graph down. Maybe I should do problem 13 as opposed to 14, because the numbers on 14s I think get a little unreasonably big for the first example. So I'm going to look at the graph of number 13 real quickly. I'm going to hit y equals, and I'm going to graph the function x squared plus 6x plus 5. I'm going to do zoom standard and hope the graph fits on a nice standard window. And it does nicely. So this parabola right here is somehow a shifting of the graph f of x equals x squared. And to figure out maybe how it's shifted, I'm going to find the vertex and talk about how this graph is compared to the graph of x squared, at least in terms of moving left and right and up and down. So I'm going to find the vertex by going second calc, selecting option 3 for minimum because the vertex is a minimum point. I'll use my arrow and I'll trace to the left of the vertex and hit enter, trace to the right of the vertex and hit enter, and then get as close as I can to the vertex and hit enter. So the vertex, I believe, is at the point -3, -4. So this graph compared to the graph of a parabola f of x equal to x squared, which I can graph on here real quickly. If I want to compare my graph to the graph of x squared, because the vertex is at the point -3, -4, I would say it got moved left 3 and down 4. It doesn't look like it's a skinny graph or a narrow graph. So if my guess was, if I want to describe the transformation for problem 13 compared to f of x equals x squared, it looks like the graph went left 3 and down 4 because the vertex is at the point -3, -4. I could make a stab at coming up with a guess of the equation of this parabola written in standard form, because to move a graph to the left 3, I need a plus inside a parentheses. So the function that I think is going to do this is going to be f of x plus 3 to move it left 3. And then for the -4 on the vertex, I probably need a minus after the parentheses. And the function that I think is going to have the same graph as this function is x plus 3 squared minus 4. This parabola right here, x plus 3 squared minus 4, will have a left 3 and a down 4 shift. And if I graph that function, f of x equals parentheses x plus 3 squared minus 4, I don't see a new graph because this function has the same graph as that function. It's the rewrite of this function in standard form. Writing the function in this form, I can tell you that this graph compares to the graph of x squared by moving it left 3 and down 4. When I look at the equation written in this form, I couldn't tell you at all that it relates to f of x equals x squared by moving left 3 and down 4. So what I'm going to need to do in this section for this particular problem is to figure out an algebraic way to come up with a rewrite of this equation so I could tell you how it compares to the graph of f of x equals x squared. And I do that by completing the square. So I'm going to do problem 13 as opposed to problem 14. My graph's not going to fit so well in my window here, so I'm going to probably just graph it freehand. So for 13a, I'm going to take the function f of x equals to x squared plus 6x plus 5 and teach you how to write it in standard form using completing the square. The first step I do in completing the square is I'm going to add and subtract c on the right-hand side. As the problems get slightly more complicated, I might have to have a number in front of this c, but we'll hold off on that at first. So first step, add and subtract c, and very specifically, that c is going to be added after the x terms and subtracted after the constant. So when I go to add and subtract 3, I'm going to add after the last x term and subtract after the constant, which is the number without the letter. If you simplified this, the c's would cancel and you'd get the original problem. Now I'm going to replace the c with a number. And you learn this in intermediate algebra, so hopefully it comes back quickly. And c is always the number in front of the x term, the number in front of the x to the first power term divided by 2 squared. So to get my c, I look at the number in front of the x to the first power term, and I put it in this template. I divide it by 2, then I square it. So the number in front of the x to the first power term, I need to use to find c, And anytime I go to find c, I take the number in front of the x to the first power term, I divide it by 2, then I square it. So in this case, that's going to be 3 squared, which is 9. So I'm ready to replace my c with a number. I'm going to get x squared plus 6x plus 9. So I change that c to a plus 9. And then plus 5. And then minus 9. So now I replace the c with a number. Next step is to factor the first 3 terms. And to combine or simplify the last 2. So on this stage, I'm going to factor these. And I'm going to combine those. The factoring should be easy. When I go to factor this and just this, ignoring the rest of the right-hand side, I'm going to create 2 parentheses. And the first need to be a couple of x's to multiply to the x squared. The signs are a couple pluses because I don't have any minuses from those 3 terms. And my last have to multiply to 9 and add to 6, and 3 times 3 will do that. X squared plus 6x plus 9 factors into x plus 3 times x plus 3. And these last numbers, 5 minus 9, gives me a negative 4. I'm going to rewrite this as x plus 3 squared minus 4. And this is considered rewriting the problem in standard form. I actually kind of came up with that. I came up with x plus 3 squared minus 4 by looking at my graph, knowing that the graph was moved left 3 and down 4. My answer to part A, the rewrite of my function for 13a, is going to be f of x. I don't need to worry about the left side. I'm just going to worry about the right side. Is x plus 3 squared minus 4. Done with the hard part, everything else is easy. Now I want to describe the transformation that occurs compared to the function f of x equals x squared. The plus 3 inside the parentheses is going to move it left 3. The minus 4 after the squared is going to move it down 4. Done with part B. Now I go to part C. I'm going to sketch a graph. I'm going to label the vertex, and I'm going to make a table of values. And in the middle of my x column, I'm going to take the number. The number I'm going to put in the middle of my x column is what I get when I take what's inside the parentheses and set it equal to 0. When I go to sketch a graph, I'm going to put negative 3 in the middle of my x column. And I might as well do this graph on another sheet of paper, specifically because this window was for graph for 14 and not for my graph. So when I go to do my table to graph for part 13c, I'm going to put negative 3 in the middle of my x column. I'm going to go bigger a few and smaller a few, or smaller a few and bigger a few. And as I go to sketch my graph, on the x-axis, I'm going to put the numbers negative 1 through negative 5. I'm going to hold off using my y-axis real quickly here because I don't know the numbers I need to put. On my y-axis, I don't know the y's. I could graph this function, or I can graph this function, or I can graph this function. It turns out that the graphs are going to look the same. I kind of already did that. So let me clear this out, and let me just show you real quickly that if I graph the function x squared plus 6x plus 5, if I graph it, it graphs like that. And if I graph my answer to part A of x plus 3 squared minus 4, you're not going to see any difference. It's going to go right on my graph. Just to show you real quickly, if I made a mistake on my rewrite, let's say I came out with x plus 3 squared minus 8. If I graphed it along with the original graph, you're going to see 2 distinct graphs. If you graph the original function and your answer to part A, when you graph it, you're only going to see one graph because the graphs look exactly the same. Now to fill in my y's, I'm going to go second table. I have two functions on my graph, so I'm seeing two y columns, but they're both the same because both the graphs have this. They're different equations, but they have the same y's and they have the same graph. So next to -5, I should have the number 0 in my table. Next to -4, I should have -3. Next to -3, I should have -4. That's going to be my vertex. Next to -2, I should have -3. And next to -1, I should have 0. And now I'm going to sketch a graph. I'm going to label the vertex because I was asked to do that. So my graph is going to have the point -5, 0. And then on the y-axis, I need to get some numbers. I need to get some negative numbers. I'm going to go down to -4. Graph the point -4, -3, -3, -4, which is the vertex. So I'm going to call it the vertex. -2, -3, and -1, 0. So this is my sketching a graph. And the vertex is the point -3, -4. That's everything that needed to be done for problem 13. So I took the time to use completing the square to rewrite the problem in standard form. Then, when it was written in standard form, I can tell you how the graph compared to the graph of f of x equal to x squared. It was left 3 and down 4, and then I made a table of values and sketched a graph. That's what we're going to do for each of the next few problems. They get a little bit hard if there's a number in front of the x squared. So I'm going to start with problem 16 and see where it takes me. It's going to fit on this nice window. You should be able to do problem 15. When I go to do 16 part A, I want to be able to tell you how this graph compares to f of x equals to x squared, and I need to use completing the square to do that. I start off this by adding and subtracting c on the right-hand side. I add c after the letters. I subtract c after the constant. Now I'm going to figure out what c is. C always has the template some number divided by 2 squared, and the number that you divide by 2 and squared is the number in front of the x to the first power term. So for this problem, the c is going to be -2 over 2 squared. The over 2 squared is from the formula. The -2 comes from the problem. This is going to give me -1 squared, and -1 squared is 1. So I'm going to rewrite this as m of x equals x squared minus 2x plus 1 plus 6 minus 1. So I replace the c with a 1. And the first 3 terms I'm going to factor. The last 2 terms I'm going to combine. When I go to factor the first 3 terms, I don't need bottoms up because there's not a number in front of the x squared. The first are a couple of x's. The signs are a couple of minuses. My last have to multiply to 1 and add to 2, or add to -2. It's going to be -1 and -1. -1 times -1 is +1. -1 plus -1 is +2. So the factoring gives me x minus 1 times x minus 1. And when I combine those, I get a 5. My answer to part A of number 16 is going to be m of x equals to x minus 1 squared plus 5. Done with part A of number 16, moving on to part B to describe the transformation. The minus inside the parentheses moves the graph right 1. The plus 5 after the parentheses moves the graph up 5. Now I'm going to make a table of value and sketch a graph. To figure out what number to put in the middle of my x column, I take the inside of the parentheses and set it equal to 0. And now I'm going to add 1 to both sides, and that tells me to put 1 in the middle of my x column. I'm going to go smaller than 1 and get 0 and -1, and bigger than 1 and do 2 and 3. So that's the table I'm going to use. For each of these problems, to make sure I'm right, I'm going to put this function in y1 and this function in y2. When I go to graph them, if I see 2 distinct graphs, then I have a mistake. My graphs shouldn't look any different, and I should get 2 identical graphs so you won't even be able to see the second graph. So first function I'm going to enter is x squared minus 2x plus 6. Second function, x minus 1 squared plus 5. Graph it. First it graphs the first function, and then it's going to graph the second function. If I had made a mistake, I'd see two distinct graphs. Since I didn't make a mistake, I only see one graph. Now I'm going to go second table, and next to -1, I need the number 9. Both graphs have 9 for the next to -1. Both graphs have 6 next to 0. Both graphs have 5 next to 1, 6 next to 2, and 9 next to 3. So I'm just going to plot those points and sketch a graph. It doesn't matter which column I pick. It doesn't matter if I use the original graph equation or the bottom equation to graph. They have the same graph. So -1, 9, 0, 6, 1, 5, which is going to be the vertex. Let me just write that down. That was told me to label the vertex in the instructions. So 1, 5 is a vertex, 2, 6, and 3, 9. So that's my make a table, sketch a graph, label the vertex. Done with everything for problem 16, so you can move on and give 15 a try. The next few problems are a bit trickier. They have numbers in front of the x's, and that's going to make the graph either narrower or wider, or flip it over the x-axis. And last semester when I taught this, my best student, or at least the student that did the best on the test, this is the only question she asked me all semester, so obviously it's very tricky. So for part 18, I'm going to use completing the square to rewrite the problem in standard form. It's tricky, tricky, tricky when there's a number in front of the x squared term. So what I'm going to do is a little bit different. So I'm going to have to, when there's a number in front of the x squared, there's some stuff you have to do before you get started. And very specifically, before I add and subtract c from both sides, I have to factor out the number in front of the x squared term. You'll notice when I wrote the problem down, I put the constant way off to the right, because when I go to factor it out, I only factor that number out from the x terms. So my first step in rewriting the problem so that I can tell if it's moved left or right, up or down, wider or narrower, is if there's a number in front of an x squared term, you pull out that as a common factor only from the x's. So right now, from the x terms, I'm going to pull out a common factor of a 4. So I'm going to pull the 4 away from the x squared and be left with an x squared. And when I pull a 4 out from the 24, I divide it by 4, and I'm left with a plus 6. Now the horrible part. That's not the tricky part. The tricky part is to add and subtract c. I forgot to write an x there. That should be a 6x. So I added c. The number in parentheses is going to wind up needing to go in front of the c. When you add and subtract c, if there's a number that you put in front of the parentheses, you need to put that number in front of the c. The reason is, if I cleared this parentheses right here, I'd get 4x squared by multiplying 4 times x squared, plus 4 times 6x is plus 24x, plus 4c, and then if I just minused 1c, the c's wouldn't cancel. In order to cancel a 4c, I have to put a minus 4c. So if there's a number in front of the x squared, two issues happen. First, I need to factor that number out as a GCF from the x terms. And when I'm subtracting, that number needs to go in front of the C. Now I'm going to figure out what C is. C is always gotten by the formula. We have a parentheses with a 2 in the denominator and a square outside that parentheses. And the number in front of the x to the first power term goes in that parentheses. I had a hiccup that I completely ignored. So there might be a break in this video that might make it hard to follow. My C is going to be 9 in this case. So C is always half the number in front of the squared term, half the number in front of the first power term squared. So now I'm going to replace the C. I'm going to go 4 times x squared plus 6x plus 9. This 4 times 9, if you clear the parentheses, gives you a positive 36. I'm going to go plus 30 minus 4 times 9, which is the minus 36 that will compare to that positive 36 that's in hiding. Now, I'm going to ignore that 4. I'm going to factor these and combine these. When I do that, I'm going to get h of x equals 4, and then I'm going to factor these into two parentheses. X squared plus 6x plus 9 factors into x plus 3 times x plus 3. And this is going to be 30 minus 36, because when you do orders of operations, you do the multiplication first. 30 minus 36 is negative 6. So my answer to part A, rewriting the problem so I can tell you how the graph compares to the graph of f of x equals x squared, is going to be 4 times x plus 3 squared minus 6. So I'm going to write that in as my answer to part A. So part A, my function is going to be h of x equals to 4 times x plus 3 squared minus 6. Now I'm going to move on to part B. Again, it doesn't look that says h of x equals 4 times x plus 3 squared minus 6. And now I'm going to describe the transformation. When I describe the transformation, the 4 in front of the parentheses is going to make it a narrow or a skinny graph. Technically, we can say it stretches it, but I like using the word narrow and wider. The plus 3 inside the parentheses is going to move it left 3. And the minus 6 is going to move it down 6. So immediately I know the vertex at 0, 0 is going to be moved left 3 and down 6. The vertex is going to go from 0, 0, down 3, left 3, down 6. The vertex should be at the point negative 3, negative 6. When I go to make my table of values, I start off to get my numbers for my x column by taking the inside of the parentheses and set it equal to 0. That's going to give me x equal to negative 3 for the middle of my x column. When I go to sketch my graph, I'm going to do negative 3, negative 4, negative 5, negative 2, negative 1. I'm going to put this function in y1. I'm going to put this function in y2. If I have a mistake, I'll see two graphs when I graph it. If I don't have a mistake, I'll only see one graph. So now I'm going to go y equals clear and clear. The original function, 4x squared plus 24x plus 30. And my answer to part A, 4 times x plus 3 squared minus 6. Hit my graph. Hopefully I only see one parabola. If I see two parabolas, I have a mistake. Check out my table now. Look for negative 5. Next to negative 5, I see positive 10 for both graphs. And then next to negative 4, negative 2, then negative 6, negative 2, and positive 10. My y's have to repeat if I have a good equation. So first point, negative 5, positive 10, then negative 4, negative 2, negative 3, negative 6, which I already knew from the shifting. -2, -2, and -1, +10. It's a nice skinny graph compared to the normal graph because the 4 in front of the parentheses makes it skinny. That's a reasonable graph. This should be more of a U than a V, but I can live with that. So give 17 a go. It's the same style of problem. Let me do your 19 just to get one of your problems done. So for 19, I should probably, when I go to do part A, think of 19 as f of x equals -1x squared plus 6x plus 4. When there's a number in front of the x before I add and subtract c, I need to factor out the number that's actually in front of the x squared by doing a 1 parentheses factoring. So I'm going to go f of x equals -1, and I'm going to factor out that -1 from the x squared and from the 6x. When I factor it out from the x squared, from the -1x squared, I'm just left with an x squared. When I factor out a -1 from the positive 6x, I flip the sign and get a -6x. Now I'm ready to add and subtract c. So I'm going to get f of x equals -1 times x squared minus 6x plus c plus 4 minus c. And when there's a number in front of the parentheses, you need to take that number and put it in front of the parentheses. So it's going to be minus -1 times c. So when there's a common factor, the minus c part gets that number in front of it. And now I have a minus 1c. That double minus is going to be negative. Forgot to close my parentheses here. So I can write this as f of x equals -1 times x squared minus 6x plus c plus 4 plus c. Now I'm going to figure out what c is. C is always easy to come up with. C in a template has a fraction inside a parentheses with a 2 in the denominator, an exponent of 2. The number that goes into the template is the number from the numerator, or from the x to the first power term. It goes in the numerator. It's going to be a -6. So c is going to be -6 over 2 squared, which is -3 squared, which is 9. So I'm going to rewrite this problem now by replacing those two c's. So I'm going to get -1 times x squared minus 6x plus 9 plus 4 plus 9, changing that c and that c to a 9. Now I'm going to factor this and combine this. The -1 I'm going to leave out front. I'm going to write this as -1. And these two parentheses factor into x minus 3 times x minus 3. The last two numbers combine to be 13. So this is going to factor into f of x equals -1 times x minus 3 squared plus 13. Done with part A. That's going to be my answer to 19A. So for 19A, the transformation of my function is going to be f of x equals to -1. I don't have to write the 1, but I like writing the 1, times x minus 3 squared plus 13. Now I'm going to make my table of values. I'm going to describe the transformation. The negative in front of the parentheses reflects it over the x-axis, or it makes it go upside down. The -3 inside the parentheses makes it go right 3, and the plus 13 makes it go up 13. I'm going to make my table of values and sketch a graph now. And my graph is going to fit on here just fine. Real specifically, to figure out where the vertex is, initial parabola f of x equals x squared has a vertex at 0, 0. If I go right 3 and up 13, the vertex is going to be at the point 3, 13. Going right 3 takes me to x equal to 3, up 13 takes me to y equal to 13. I'm going to take this number, basically just change its sign and put it in the middle of my x column. To get my x column of my table, I take the inside of the parentheses, set it equal to 0. That gives me the number for the middle of my x column, which is going to be 3. I'm also going to put 2, 1, 4, and 5 in the middle of my x column. And I'm going to graph both this in y1 and this in y2. If when I graph it I see two distinct graphs, I made a mistake. In fact, let me show you if I make a mistake, what happens. Let me enter these functions. Let me enter negative x squared plus 6x plus 4, and then negative 1 times x minus 3 squared plus 13. Because I think my answer is right, I should only see one graph. I should change my window a little bit here in a second. If I had made a mistake, let's say this answer I came up with, instead of plus 13, I came up with plus, I don't know, plus 9. If my answer was wrong, when I graphed it, I'd see two distinct graphs that don't match up. So you could tell you're wrong if you don't have two distinct graphs. Let me change this back to the right answer. And my window needs to go up to 13 because the vertex is at 13. Let me change the y max in my window, maybe to 15, just so I can see that vertex of 13 better. Now I can see the whole parabola if it bugged me that I didn't see the whole parabola. And let me steal my calculator, my table. So second table, next to 1, I need 9. Next to 2, I need 12. Next to 3, I see 13. Next to 4, I see 12. Next to 5, I better see 9, which I do. Graph the points, so 1, 9, 2, 12, 3, 13, which I already knew was the vertex, 4, 12, and 5, 9. And this is just supposed to be a normal width. The 1 in front of the parentheses doesn't make it wider or narrower. My graph starts to get a little bit distorted because my y-axis went on the 14s and my x-axis went on the 10s. As you start to change, if the y-axis has a different numbering than the x-axis, it can make a graph look narrower when it shouldn't or wider when it shouldn't. But I didn't want to make my x-axis go to 14 too, so I get a little distortion in my graph. So that was your problem 19. I'm going to move on and do problem 22 and let you do problem 21. So for 22, I'm going to start by doing part A, using completing the square to rewrite the problem. And to do that, because there's a number in front of the x squared term, I need to factor that number out. So I'm going to start off rewriting the right-hand side, going negative 2, and then I'm going to factor out a negative 2 from the x squared, be left with a positive x squared. Factor out a negative 2 from the positive 8x, be left with a negative 4x. Now I'm going to add and subtract c. That number that's in front of the parentheses needs to go in front of the c that I put after the number. So I'm going to get minus 4x plus c inside the parentheses, and then plus 3, and then minus from the formula, and then I put a minus 2 in front of the c. So it's usually plus c minus c, but in this case it's going to be plus c minus negative 2c. The number that goes in front of the parentheses goes in front of the c. Now I have a double negative there that I can make positive, so I'm going to get g of x equals to negative 2 times x squared minus 4x plus ce plus 3 plus 2c. Now I'm going to figure out what c is. C always has the template that you have a fraction inside a parentheses with a denominator of 2 and a square outside the parentheses. The c is going to get tagged with that negative 4 because it gets the number in front of the first power term when you go to finish up the computation for the c. This is going to be negative 2 quantity squared, which is positive 4. So I'm going to write this as g of x equals negative 2 times x squared minus 4x plus 4 plus 3 plus 2 times 4, plugging in 4s for both the c's. I'm going to factor this. That's going to factor into x minus 2 times x minus 2. And I'm going to combine these. These come out to be 3 plus 8, because 2 times 4 is 8. I do the multiplication first. And 3 plus 8 is 11. My answer to part A for number 22 is going to be g of x equals negative 2. I'm going to write that as x minus 2 squared and plus 11. Done with part A. For part B, for the transformation, the minus in front of the 2 is going to reflect it over the x-axis or make it go upside down. The 2 is going to make it narrow. The minus 2 inside the parentheses is going to make it go right 2. And the 11, the plus 11, is going to make it go up 11. The narrow part in the reflecting I can't do so well, but if I take the point 0, 0 and move it right 2 and up 11, I'm going to get to the vertex. The vertex of this is going to be at the point 2, 11. I don't need to know that for certain because my table will give it to me. So for my table, I'm going to put a 2 in the middle of the x column and get smaller and bigger. The reason 2 in the middle of the x column, because if I take x minus 2 and set it equal to 0, you get x equal to 2. So now I'm going to get my y's, and I'm going to graph both functions. So y equals clear, clear. The initial function is negative 2x squared plus 8x plus 3. And my answer is negative, to part A, is negative 2 times x minus 2 squared plus 11. And now graph it, make sure I only see one graph. If I see two graphs, I've made a mistake. I only see one graph. Now second in table. Next to 0, I get the number 3. Next to 1, I get 9. Next to 2, I get 11. Next to 3, I get 9. Next to 4, I get 3. And I'll just plot all the points, connect them with a parabola, and be done. So 0, 3, 1, 9, 2, 11, 3, 9, and 4, 3 is up here. Duh. 3 and 3. This graph isn't going to look particularly narrow because the way I have the y-axis incremented, it goes up to 14, and it makes the graph look a little bit wider when that happens. All right. Give 21 a go, and then we just have one more problem in this kind of problem, then we get a whole new kind of problem, which they're not particularly hard. All right, so let me do 23 just to get another one of your problems done. So for 20, and you can pause the video and do 23 by yourself if you want, and then just check if you like. So for 23, my first step is I'm going to factor out a negative 3 from these two terms. I'm going to write this as f of x equals negative 3. Take the negative 3 away from the x squared, be left with an x squared. Divide that by 3 and flip the sign and be left with a positive 4x. So I pulled out the common factor from the x terms. And now I'm going to add and subtract c. Inside the parentheses, I just put a c. After the plus 1, I usually have a minus c, but I have to attach that minus 3 to it. So I get a minus 3c. The double negative goes plus. So I get f of x equals minus 3 times x squared plus 4x plus c plus 1 plus 3c, because that double negative goes plus. To figure out the c is going to be half of this 4 squared. That's going to be 2 squared, which is 4. So I'm going to write this now as f of x equals negative 3 times x squared plus 4x plus 4 plus 1 plus 3 times 4. I'm going to factor that and get negative 3 times x plus 2 times x plus 2. And I'm going to combine that. That's 1 plus 12, which is 13. So this is going to give me f of x equals negative 3. The x plus 2 times x plus 2 I'll write as x plus 2 squared, and then plus 13. To describe the transformation in part B, the negative reflects it over the x-axis. The 3 is going to make it narrow. If it was between 0 and 1, it would make it wide. The plus 2 is going to move it left 2, and the plus 13 is going to move it up 13, which means the vertex is going to go left 2, up 13. It's going to be up here somewhere, so it's going to be at negative 2, 13. Because if I start at the point 0, 0, go left 2, I get x equal to negative 2. Up 13, I get y equal to 13. So that's going to be my vertex. Now I'm going to make a table of values and sketch a graph. I'm going to enter both functions. So y equals my original function for number 23, negative 3x squared minus 12x plus 1. And my rewrite, negative 3 times x plus 2 squared plus 13. When I go to set my window, I have the y at 15, that's good enough. My y had to go up to 13. If I see two graphs, I've made a mistake. I only see one graph, so I did well. So now second table, and I didn't do my table. In the middle of my x column, I need the x coordinate of the vertex, which is negative 2. And then I'll go negative 3, negative 4, negative 1, 0. So next to negative 4, I get 1. Next to negative 3, I get 10. Next to negative 2, I get 13. Next to negative 1, I get 10. Next to 4, I get 1. So plot my points. Negative 4, positive 1. Negative 3, positive 10. Negative 2, estimating 13. Negative 1, positive 10, and 0, 1. Now the graph is going to look narrow because my window goes from negative 10 to 10 on the x-axis without, I made the 13 kind of off my graph, and it shows me the narrower better. If 13 was at the top of this, and it would make the narrowest not show up. All right, so that's that kind of problem. We have one kind of problem left, and they're actually kind of easy. I don't remember asking these on a test, but I could. I just don't remember doing it. So the problem for 25 has a parabola with a vertex negative 1, 4, and it has a point negative 2, 14 labeled. And I'm supposed to tell you the equation of that parabola. My problem number 26 has the equation vertex 2, negative 3, and it has the point negative 1, 13. My parabola, if I want to find an equation in nice standard form, I know that this graph went right 2 and down 3, so that inside a parentheses that has a square outside of it, I'm going to need an x minus 2 squared. So my equation for my parabola to get a vertex that has an x coordinate of 2 needs to take the parabola that has a vertex at 0 and shift it to the right 2. So what I'm going to do is try to piece together a function, and I start looking at the vertex. The vertex is going to help me understand a lot of what the function is. So a minus 2 inside of parentheses will get the vertex to have an x coordinate of 2. To get the vertex to have an x coordinate of a y coordinate of minus 3, it needs to go down 3. A minus 3 will do that. So the function f of x equals x minus 2 squared minus 3 will have a vertex at 2, negative 3. If I just graphed that function, y equals x minus 2 squared minus 3, and graphed it, when I go to find the vertex, if I go second, calc, minimum, trace to the left of the vertex, hit enter, trace to the right of the vertex, hit enter, and then hit enter on a guess, I get the vertex that rounds to 2, negative 3. I'm not guaranteed that this goes through the points negative 113. To force it to go through the point negative 113, I'm going to try to get a number in front of the parentheses, because the standard form of a parabola has a number in front of the parentheses, and then an x plus or minus a number squared, and then a plus or minus a number. Well, I have most everything. I know that what the parentheses looks like. I know the number after the parentheses. I just don't know what number goes in front of the parentheses, and it's real easy to get the number that goes in front of the parentheses. I'm going to take the additional point, and I'm going to change the f of x symbol to the y coordinate of that initial point, and I'm going to change the x to the x coordinate of that additional point, and I'm going to solve for the number that goes in front of the parentheses. So my answer to question 26, the equation of this parabola can be found. First, the equation of this parabola can be found by first setting up putting the vertex into the equation of the parabola, and then taking the point and plugging it in for the f of x and the x, and it will help me find the y. So this is going to give me 13 equals a times negative 3 squared minus 3. This is going to give me 13 equals to 9a minus 3. I'm going to add 3 to both sides. This is going to give me 16 equals to 9a, and then I'm going to divide by 16, by 9 should I say, and I'm going to get a as 16 over 9. I claim the equation of this parabola is going to be f of x equals 16 over 9 for the a times x minus 2 squared minus 3. Let me put this equation into my calculator and show you that it does perfect for me. So I'm going to put parentheses 16 divided by 9 times x minus 2 squared minus 3 and graph it and show you that it still has a vertex of positive 2, negative 3. This is 2, negative 3. And show you that it goes through the point negative 113. Let me go to my table, go second table, and next to negative 1 I see 13. So I know perfectly that this graph goes through the point negative 113, and I can look at it and see that it has a vertex of 2, negative 3. Let me walk through 25 with you. So to do problem 25, I'm going to create an equation, and the equation is going to be f of x equals some number times a parentheses with an exponent of 2. Because my vertex is from the 0, 0, it's right 1 down 4. To get right 1, I'm going to need an x minus 1 in my parentheses. To get a down 4, I need a minus 4 after the parentheses. So this is going to be this is going to give me a parabola that has a vertex of 1, negative 4. The minus 1 makes it go right 1. The minus 4 makes it go down 4. To make the parabola go through the point negative 2, 14, I'm going to plug 14 in for the f of x, and I'm going to plug negative 2 in for the x, and I'm going to solve for a. This is going to give me 14 equals a times minus 3 squared minus 4. This is going to give me 14 equals 9a minus 4. I'm going to add 4 to both sides. This is going to give me 18 equals to 9a. And then I'm going to divide both sides by 9. This is going to give me 2 equal to a. I'm going to change this a to a 2, and your answer to problem 25 is going to be f of x equals to 2 times x minus 1 squared minus 4. I'm going to graph that and make sure it has a vertex of 1, negative 4, and peek at my table and make sure it goes to the point negative 2, 14. So to check my work in 25, I clear out the cruddy function that I had in there and go 2 times parentheses x minus 1 squared minus 4, graph it, see if the vertex is at 1, negative 4. I can't tell that for certain, so let me go second calc minimum, trace to the left of the vertex, hit enter, trace to the right of the vertex and hit enter, and get close to the vertex and hit enter. And that, I believe, is the point 1, -4. So I believe it has the right vertex. Now let me make sure it goes through the point -214 by going second in table, going next to -2 and making sure there's a 14. There is, so it has the right vertex. It goes through that point. My answer must be right for problem 25. So for problem 27, your vertex is at the point -1, 5. And the point that it has to go through is the point 0, 2. For problem 28, my vertex is the point -2, 6, and the extra point it has to go to is the point 0, -6. My equation for problem 28, to go left 2 and up 6 from 0, 0, to get a vertex of -2, 6, I have to have a +2 inside my parentheses to move the graph left 2, and then I have to have a +6 after to make it go up 6. So to go left 2 and up 6, +2 is left 2, +6 is up 6. And now I'm going to figure out what number goes in front of the parentheses by putting a -6 in for the f of x, and I'm going to plug a 0 in for the x, taking that extra point and splitting it up between the f of x and the x. This is going to give me -6 equals, this is going to be 4a plus 6. I'm going to minus 6 from both sides and get -12 equals to 4a. And then I'm going to divide both sides by 4 and get -3 equals to a. My answer to 28 is going to be f of x equals to -3 times x plus 2 squared plus 6. I'm going to check this by graphing. I'm going to go y equals clear -3 parentheses x plus 2 squared plus 6. Graph it. Check the vertex by going second calc maximum, trace to the left of the vertex, hit enter, trace to the right of the vertex, hit enter, get as close as you can to the vertex and hit enter. And it's the point -2, +6. My vertex is right. Now check for this point in my table by going second table, looking next to 0 and making sure there's a -6. There is. So I found the vertex. The graph goes through that point. I know my answer is correct. So give 27 a go. For 29, your vertex is a point -2, 6. Your extra point is a point 214. For problem 30, my extra point is a point 45. My vertex is a point -2, -4. To get started on number 30, I'm going to write f of x equals a times a parentheses with a square. My vertex is left 2 down 4. To get a left 2, I need an x plus 2 in my parentheses. To get a down 4, I need a -4 afterwards. I'm going to split this point up now. The y coordinate I put in place of the f of x. The x coordinate I put in place of the x. This is going to give me 5 equals, this is 6 squared, so it's going to be 36a minus 4. I'm going to add 4 to both sides. Gives me 9 equals 36a. And I'm going to divide both sides by 9. And it gives me, divide both sides by 36. And that gives me 1/4 equals to a. So my answer is going to be f of x equals 1/4 for my a, and then x plus 2 squared minus 4. Let me check this real quickly by graphing it. So y equals clear parentheses 1 divided by 4 times x plus 2 squared minus 4. Graph it. I'm going to make sure it has a vertex of -2, -4. It's a wide graph because of that fraction. So second calc minimum, trace to the left of the vertex and hit enter. Trace to the right of the vertex, hit enter. Trace close to the vertex and hit enter. And I should get something that's either exactly that or rounds to that. When I get this, I get that rounds to -2, -4, so I feel good about that. Now, second table, make sure next to positive 4, I see a 5. And next to positive 4, I see a 5. So I feel really good about my answer. So my answer is right. Give 29 a go. And I wanted to stop the video. If you want to try problem 31, if you feel good enough about these problems, skip it. I'm going to skip 32 just because the video is already an hour long, and I don't like my videos to get longer than an hour. And I don't remember asking these types of problems on the test, and they're not particularly hard. So if you feel motivated, do 31 and check your answer. If you don't, skip it. And I'm going to stop right here.